Hi, welcome back to the world of factorization. So today we have another problem, but this one's different. We know what x's value is. If x is equal to root of 6 by 7, then evaluate x plus 1 by x squared whole squared. So instead of putting this in just right now, how about we just simplify this equation and then we can substitute with x's value. So over here I have this little multiplication where we have to use this for the first step. So a plus b whole squared is equal to a squared plus 2ab plus b squared. So in this case, x would be a and 1 by x would be b. So now we have to let's open the parenthesis and whole square x plus 1 by x. So we have x squared plus 2ab. So let's find ab first. X times 1 by x would be 1. So 2 times 1 is 2. X squared plus 2 plus 1 by x squared. Okay. So 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 let's change this equation to x squared plus 2 plus 1 by x squared, because 1 squared is 1 and x squared is x squared because we haven't substituted yet. Now we're going to substitute the value since it's simplified. So x is equal to root of 6 by 7. So we have this squared plus 2 plus, we're going to need a lot of space for this, 1 by, and x squared would be 6 over 7. Alright, so now we have 6 by 7 plus 2 plus, this would turn into 7 by 6. Okay, so now let's start with the fraction addition. We would get, hold on. Let's use this little corner to add. We have 6 by 7 plus 7 by 6. So the least common multiple of 6 and 7 is 42. So we have 6 times 6 divided by 7 times 6 plus 7 times 7 plus, divided by 6 times 7. Okay, so we have 36 plus 49 divided by 42. So let's add the two numbers on the numerator. We have 30 plus 40, 70. 70 plus 15, we get 85. So we have 85 divided by 42. So let's put this in here, 85 by 42 plus 2. So if we turn the 2 into a fraction with the same denominator, then I'm going to need way more space for that. Or 85 by 42 plus this would be 84 by 42. So we have to add 85 and 84 since the denominator doesn't change. So 80 plus 80 is 160. 160 plus 9 is 169 divided by 42. So this is our answer. And notice how we got this from this equation. So notice how our answer in the numerator is 6 plus 7 is 6 plus 7 is equal to 13, right? So the numerator is 13 squared. Notice how the denominator is 6 times 7.
Start.
So now let's start on the next problem. So I'm going to show you an interesting triangle called the Pascal triangle. But before we get to that, we have some things to solve. So x plus y, this whole thing to the power 0, has to be 1 because any number to the power of 0 is always 1. Now we have x plus y to the power 1, which is obviously x plus y. Over here we have x plus y whole square. We have x squared plus 2xy plus y squared. Okay, last one. We have x plus y. We have x plus y cubed. So instead of solving this, we can substitute this value into here. So let's solve this in this way. X plus y times x squared plus 2xy plus y squared. Okay. So just like we did in factorization, instead of going forward, we're at the last step, we're going to go one step back. So it would be x times x squared plus 2xy plus y squared. So we have this, but this isn't all. We still have y times x squared plus 2xy plus y squared. So now let's multiply x with this humongous thing. We get x cubed plus 2x squared y plus x times y squared plus over here we get yx squared plus 2xy squared plus y cubed. Okay, now we have this humongous answer. And now we get to go to the interesting part. Before, there's one more step before we get to the interesting part. We can shorten this to a short answer. We have x cubed plus, okay, we have 2xy squared, and we could turn this into x squared y. So that would get us to 3x squared y plus we have xy squared and we have 2xy squared. So that would be 3xy squared plus y cubed. Okay, now it's all simple. We shortened the answer. Now I'm sure we get to go to the interesting part. Okay, like I said, we're on to the interesting parts. So I split this into two parts. One for the whole working part, another part for the interesting one. So let's do this part first so that we understand what the interesting part is. I know now it looks like a whole bunch of random numbers, but once you understand this, it won't. So we have x plus y to the power 0, which is 1. X plus y to the power 1, which is obviously x plus y. We have x plus y to the power 2, x plus y whole square, which is x squared plus 2xy plus y squared. Now, and then we have x plus y, the whole thing to the power 3. We get x cubed plus 3x squared y plus 3xy squared plus y cubed. Now we have x plus y, whole thing to the power 4. We have x to the power 4 plus 4x cubed y plus 6x squared y 6x squared y squared plus 4xy cubed plus y to the power 4. Last one and longest one is x plus y to the power 5. We get x to the power 5 plus 5x to the power 4y plus 10x cubed y squared plus 10x squared y cubed plus 5xy to the power 4 plus y to the power 5. Okay. My throat's dry. It's so long. Okay, interesting part. So now let's write down the coefficients. So we have so over here we have 1, and then both of these, the coefficients are 1, and then for this it's 1, 2, 1. For this one it is 1, 3, 3, 1. For this one, this humongous one, we get 1, 4, 6, 4, 1. And for this one, we have 1, 5, 10, 10, 5, 1. So instead of memorizing this triangle, we can notice an interesting pattern here. Every number is equal to the sum of the two numbers above it. For example, 5 is equal to 1 plus 4. And 10 is equal to 4 plus 6. Again, same thing, 10 is equal to 6 plus 4. And 5 is equal to 4 plus 1. So if you keep going up, you'll notice that every single number is equal to the sum of the two numbers above it.